Hello everyone, I'm Professor Neerav Mehta from LG Institute of Technology and Engineering. So today I'm welcoming you to my subject called Automobile Component Design. In today's session, we are going to discuss about efficiency of worm and worm wheel, and then we are going to discuss about strength of that worm wheel. Efficiency is mainly going to deal with this worm, and strength will going to deal with wheel. So previously, we have discussed about different terminology and different aspect which we are going to use in this efficiency for that worm and worm. So in this session, in this particular session, we are going to derive efficiency equation for our worm and strength equation for our wheel. Strength is a basically equation which directly going to deal with your wheel and efficiency will going to directly deal with your worm. Why this efficiency? Because as you know that worm and worm will transfers higher amount of velocity ratio. So it comes under higher amount of power transmission as well as heat efficiency. So you have to derive this efficiency equation to find out what amount of efficiency is required to transfer this power. Okay, I hope you understand this. Let's move on to this equation point of view. So efficiency, as you know that efficiency is nothing but work done divided by what is out input we have given in that or input power we have given. So it is ultimately work divided by power given. So here our efficiency for this worm and worm will, here our efficiency for this worm and worm will is always going to deal with our velocity ratio. How? So in the case of worm, the efficiency will going to be 10 lambda into cos phi minus mu into 10 lambda divided by cos phi 10 lambda plus mu. So here you can see this efficiency equation is mainly depending on this lead angle, our normal angle which is made by teeth which is phi, and mu which is coefficient of friction. So lambda is nothing but lead angle, phi is normal, or you can say pressure angle. So normal pressure angle, and mu is coefficient of friction. So this is equation to find out efficiency of your worm and worm. This will going to directly affect to our velocity ratio as well as power transmission. How? This lead angle is nothing but containing our pitch and our velocity ratio. So that's why it will going to directly affect our efficiency. Second thing, the efficiency is maximum when there is a condition to find maximum efficiency where 10 lambda should be equals to under root 1 plus mu square minus mu. Okay, 1 plus mu square minus mu. That is condition to find out maximum efficiency. As well as at the same time, if angle here, or you, if I want to convert this equation into only in terms of tangential of all the values, then the equation will goes like this: 10 lambda divided by 10 lambda plus phi 1. So this phi 1 is nothing but mu, so phi 1 is equals to mu, which is angle of friction. So this is and this is what we have discussed about efficiency of our worm. Clear? Here we haven't discussed about strength of our worm and worm will. So this equation will going to mainly deal with the efficiency of our worm. I hope you understand about this aspect of efficiency. So let's recap once again. This efficiency is mainly deals with our velocity ratio and lead angle. How velocity ratio? This velocity ratio will going to directly affect our lead angle. So this is what our equation will all about is all about. This will going to help you to find out this lead angle, as well as sometimes you are asked to find out this efficiency. I hope you understand about this efficiency. So now let's move on to the next point, which is to find out the strength of our gain. Clear? So what is strength? So as you know that strength will going to be directly amount of the capacity of our gear to carry amount of load. Clear? In the case of gears, as we know that in a spur gear or helical gear, it is a thrust load. So here our wheel is nothing but a spur gear or a helical gear. So strength will directly derive through that equation of a thrust load, which is Wt, which we have always came across, which is sigma 0 into Cv into pi into b into m into y. Now, in the case of worm and wormhole, pinion will always going to be that worm. So here, this equation will going to exclusively depend on our wheel, and which we called as a gear. So y is always going to be yg. So here you have to find the y, or you can say tooth form factor of gear rather than pinion. So you have this certainty in this equation, so you don't need to find what your design for a strength, whether it is for pinion or whether it is for a gear. Second step, because of this yt or wt, there is also called axial force, and axial force will directly depending on your thrust load, and axial force is nothing but axial force will going to act on your which is going to directly affect on your Wt. So axial force Wa will be Wt divided by cos Wt divided by tan lambda. So our axial load, this axial load will going to act upon your worm. Clear? That Wt it is act on your wheel. So Wa will act on your worms. Clear? I hope you understand this. Now sigma 0, it's also for that sigma g, because as I have told you, in the case of worm and worm wheel, strength is always going to determine of that R gain rather than worm. So CV will be for this worm is always going to 6 upon 6 plus V. So here we know that where V is the velocity of our gear. So velocity will going to be look like this pi dg ng by 60. So this will going to be our velocity. Now yg, what will going to be yg? The yg for 14 and a half, 0.124 minus 0.684 by tg. This is for 14 and a half when our phi is 14 and a half degree. Clear? For 20 degree, yg will be 0.154 minus 0.96912 divided by Tg. This is for 20 degree. So these are our tooth form factor. Now let's discuss about Wd, which is dynamic load. So Wd will going to be Wt by Cv. In the case of our worm and worm wheel, Wd will going to be Wt by Cv. Clear? Okay. So actual tangential load is Wt and Wd is dynamic load. Now let's discuss about static load. for a static load WS, it is sigma E, which is endurance strength. Here, everything will going to be same pi m y. So this is your static load. Here we are not going to multiply this with CV. Clear? Or you can also call it a flexion load. Now WW, which is nothing but let's discuss this in next slide, which is WW. Clear? WW is nothing but wear load. Clear? Wear load WW, which is equals to DG into B into K, where DG is nothing but diameter of gear, B is our face width, K we can find out K from sigma ES square into sine phi divided by 1.4 into 1 upon EP plus 1 upon EG. Clear? For this particular gear, we can take it as standard value for this. We will going to discuss in when we are going to deal with an example. So I hope you understand all the aspect of this strength and efficiency very well. This two aspect will going to affect or will going to implement in our design of our worm and wormhole. I hope you understand it very well. Let's recap the strength once again. Strength, it is nothing but our thrust strength against thrust load, which is WT, which is sigma 0 CV into pi into B into Y into YG. Here, where and from that we have to find this WA, which is axial load act on your worm. Clear, which is WT here WT by 10 lambda. 10 lambda is the lead angle. Clear? Where CV is 6 upon 6 plus V and V is pi dg ng upon 60. Here we are going to use each and every aspect of design for a gear rather than worm. Clear? YG will going for 14.5 degree. It is 0.124 minus 0.684 divided by dg, and for YG, which is 20 degree, which is 0.154 minus 0.912 divided by dg. Dynamic load, which is WT upon CV, and static load, which is sigma E B pi m into Y. Sigma is nothing but flexure strength, or you can say endurance limit. In next slide, we have discussed about wear load. This wear load is DGB into K, where K is sigma E square endurance limit sine phi upon 1.4. Phi is normal pressure angle. EP and EG is elastic limit of our warm and warm. I hope you understand this all the aspect of this efficiency and strength very well. In next video, we are going to have a case study of our warm and warm will. I hope you understand these factors and different aspect of this warm and warm will well. Um, if you have any doubt regarding this efficiency and strength of bomb and bomb will, you can directly contact me. Thank you. Thank you so much. So we are ending with here.